Now let's get into types of chemical reactions. Let's actually see these being used. Let's talk first about a composition reaction. Composition reactions are also called synthesis reactions, and occasionally you will also read them as combination reactions. I don't know why they use different names, but they do. All composition reactions take on the generic form of A plus B yields C. Notice one product. Extremely important. One product is being created. Now, typically, when you're talking about a synthesis reaction, in like 90% of the situations, you are talking about two elements combined to form one product. Example, carbon plus oxygen yields carbon dioxide. Okay? C plus O2 yields CO2. Or, as I used before, Na plus Cl2 yields NaCl. Both of these are composition reactions. Now, so people always ask me, what is up with the twos? Because notice, no two, no two. Yet, oxygen and chlorine both have twos. Well, these elements are what are called diatomic elements. Di meaning two, atomic meaning atoms. So these are elements that when we write them as an element, in their elemental form, like O2, Cl2, chlorine gas, oxygen gas, whenever we write them in their elemental form, they will always have a 2 subscript because there are 2 atoms in that particular molecule. Whereas carbon, well, carbon is only 1 atom. It's monoatomic. So it never has a 2, it never has the 1 because, again, 1s are implied. There are 7 diatomic elements. Iodine, bromine, chlorine, fluorine, oxygen, nitrogen, hydrogen. Okay. Now the mnemonic. Of course, there's always got to be an easy way to try and remember things. Well, we just learned the periodic table, so some of you have learned mnemonics for that. Or you know, you did the planets, my very excellent mother just brought us 9 pizzas, etc. Well, let's talk about a mnemonic for memorizing the diatomic elements. I bring clay for our new house. I bring clay for our new house. Iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. These 7 elements are diatomic, meaning whenever they're written by themselves, they have a 2. Now, I want to point out that the 2 or the 1 in the compound comes from the fact that there's a charge difference. Carbon is +4, oxygen is -2, it would be 2 to 4, and obviously reduced down to 1 and 2. Sodium is +1, chlorine is -1. They balance because they are equal to each other. That's why the 2 is there in the compound. But the 2 does not necessarily carry over from left to right. Important. Memorize that, or don't memorize it. Remember that. Do not forget that. The numbers in a compound come from the charge differences, not from the numbers that are on the reactant side. So here's an example of a composition reaction. Magnesium, as we know, comes in long, thin gray strips, and it's not a fancy metal, something very simple. Hold it up in front of the camera for you. This is magnesium, nothing great. And right now it's actually combining with the oxygen that's in the air, but it's a really slow reaction. So I'm going to speed it up, and I'm going to speed it up with this Bunsen burner that's sitting behind me. And so what I'm going to do is I'm going to stick the magnesium. Just going to adjust my flame real fast. Okay, so I'm going to stick my magnesium into my fire, and you'll see fairly quickly a very bright chemical reaction. So bright it actually blurs out the screen. So that is an example of magnesium combining with oxygen to form magnesium oxide. A nice composition reaction, also a great example of combustion.